this video, I'm going to answer one of the questions asked in the comments. And this question comes from Deepak. And he says, "Thank you for the informative tutorial. It was very clear and helpful. I have a couple of questions. Are there any code libraries or programs available that can generate hydrogen bond clusters such as water, ammonia, and hydrogen fluoride?" I think there should be some programs out there which can do some of these hydrogen bond clusters, but I'm not aware of any. But one of the ideas that I could give you is find hydrogen atoms and some of the hydrogen bond acceptors like nitrogen and oxygen, and find the distances between them, and if the distance is in the hydrogen bond uh, radius, you can consider it to be a cluster. So you can write a code yourself, but I am not aware of any code, but there may be some codes which people have written which would be available. But for this video, what I'm going to do is answer the second question in more detail, which is it possible to automate multi-wave function which is freely available using Python script. So I have a lot of video tutorials on how to automate using Python, but all of them were using a Python interface. So there's already a pre-existing Python code that runs the software in the backend. But what if you have something like multi-wave function that cannot be run using Python? So in this video, what I'm going to show you is how to write your own Python script to run some code like multi-wave function. So instead of going for multi-wave function, let's go with XTB. So XTB is a smaller package and it's easier to install. We have a pre-built library for it, so I won't go into multi-wave function, but let me just demonstrate how to do with XTB. So let me first fetch the pre-built library, and if you want to look into more detail of what XTB is, you can click on the link over here and it should take you to this interface. The documentation over here should tell you that there is already a Python integration for XTB. But we are not going to use the Python integration, we'll write our own way of running XTB. So we see that this is downloaded and it should be a tar file, and we can click on the files over here and see that it's a tar file, and this is pretty common way of compressing. It's like a zip file, and what we can do over here is extract it. So to extract it, what we do is use the tar program to do it, TAR, and the exclamation mark over here means it's a command line. I'm using a Colab, and if you want to access command line, you put an exclamation. So let me run this code, and it should extract everything in XTB -dist. And as you see, a new folder is created, XTB-dist, and within that we should see some of the other folders. I haven't talked in greater detail about installing software in command line or Linux, but we usually end up with some libraries like this, which is bin. Bin should have your executable, which runs the actual program, and include and lib and share or some other C program or something else that are needed to run the code. So in order to run the code, what we can do is copy this path and paste it at the bottom, which I've already done. So if I paste something over here, the path that I copied, it should give me the location to the executable. And if I want to run it, I again go to the command line and run this executable. But as a demonstration over here, I'm not going to give any input file, but just use the -version to show what the version of the code is. So if everything is good and the code works, we should see the version which is 6.7.0. So this is a command line that we have run, a command in the command line, and we see it works. But what if you want to do this in Python, right? And let's say you have 10 files and you want to automate it. There's a way to do it in shell script, but let's do it in the Python way. So let's see how to run a code in Python. One way to do it is using OS. So let's import this library, and running the command is as simple as copying the entire thing and pasting it within double quotes or single quotes, pasting as a string in this os.system function. What it will give you is not the output that we saw above. Instead, it says it's 0. So what it means over here is it's running the code and this termination is successful. If it's successful, it's 0. If it's not successful, it should give some big number. So let's try this. Okay. So let me remove an n from here and run this. And now we see it's a very big number. So this shows that the code didn't execute successfully. And we can use a small code block like this, which is return code, capture what the return code is, and if the return code is equal to 0, you can say it's success, or you can use some processing files, or some code that processes your files and gives you output what you need. So let's see, when we run this, if it's success, it says it's 0, and you can try messing with this and see what happens if you remove an n from here. It should be printing failure. So going back to the command line execution that we first did, so it should give us some output, and the thing that I want to discuss over here is whatever you see on the screen is just displayed and it's not saved anywhere. It's the same thing what os.system is doing. It's running the code and it's telling you it's done, and it's not saving any file. But if you want the output that's displayed on the screen to be saved, what we would need to do in Linux is pipe it. So this is called piping. So we say the version should be piped into out.system, out_system, and there should be a file that's generated. So if we run this, it'll say it's completed. But if you want to see the on-screen display that it did, we can go back to the files and look at the system out_system. We should see the same thing that we saw when we executed it in command line. So as you see, we can capture whatever we wanted, and it's very simple in os.system. But if you need more control, and if you need to read the output file or output whatever was displayed and manipulate that, os.system is not something that I would recommend. So in that case, we would need to use the subprocess. So subprocess is another library which is running another process. So let's run this. And one of the things that we can use in subprocess is popen. Popen, what it does is it opens another process and it runs the process parallelly. So it's called popen. So over here, what we can do is the same thing that we did above for os.system, but we need some additional commands called shell. We are running a shell script or command line, so shell equal to 2. And if you just hover over this popen, you'll see a bunch of things that you can do. There is std out, so this is the output file if you want to capture the output, if there's input, and if there is some errors if you want to capture. So we can do all of this with popen. os.system does not allow all this functionality. So if we run this, it should give something like none, return code, and if you want to look at the output again, so it should be popen. It should generate the same output that we saw before, but it's using popen. But if we want to read the output that was generated by the code that we just ran, we would need to read the file that was generated, which is out_popen, and then do some text formatting or running text code. But there's another way to do it, which is a run. So run is very convenient to use, and you can tell it to capture the output. So by default, it will not capture the output, and once we say capture the output, it will also capture the output, and we can directly read the file using the run. So let me show you. So in this case, I assign p equal to subprocess1, and the same thing. Just note that I'm not using the piping over here, which is out, the greater than sign and out. So this is piping. This is directing the output to something. There's no need of doing that using run. It will automatically direct the output to this p. And once that is run, what we can do is the output file is usually what the piping was, and if we just run this, p.std out, we should see the output that we saw above. But in this case, it's in more Python version where there's slash n, there are spaces, and all of that is equivalent to what we see on the screen. As you see, there's new line characters everywhere over here, and everywhere over there there are new line characters, so it's same as that. So one will give you more options to handle processes, and this is something that you can explore more, and there's a lot of documentation into this, but it's same as copying the command line, pasting it here, and moving forward. So as you can see in this video, I've shown you how you can use Python to run a code that's not written in Python. I hope you like this video.